After this, we move on to another important aspect in our planetary system, that is Earth's satellite, that is the moon. Now, moon has again fascinated amongst all the civilizations, a majority of them, since its inception. The inception of civilizations, obviously, moon has been in existence close to around, again, 4 to 4.5 billion years before present. Now, when we talk about Earth and moon, moon is the satellite of Earth because it keeps on rotating around the Earth and moving around the Earth owing to the gravitational pull of attraction of planet Earth. Now, various different theories have been floated time and time again regarding the origin of moon. You have had theorists since the time of Kant and Laplace. They have been postulating various hypotheses regarding how moon could have been created. Now, amongst all the various theories in existence, now overall, we do have a kind of a theory which is acceptable. But before that, let us take a look at the basic features of the moon. So basically, when we talk about the moon, moon is Earth's only natural satellite. You have certain planets such as Jupiter, you have planets such as Saturn, which have multiple moons in existence. Earth has got only one. Now, it orbits the Earth at an average distance of close to around 384,000 kilometers. And basically, moon is a bit more than 1/4 the size of Earth. Here, the gravitational pull is also much lesser because the size is less. So obviously the mass will be less. When the mass of an object is less, the gravitational pull of attraction is also less. So moon's gravitational force is close to around 1/6 the gravitational pull of attraction of planet Earth. That is why in all those iconic videos that you see of moon landing, you would see people hopping around the moon because the gravitational pull of attraction is very, very less. Now, its gravity influence the Earth's tides. The moon will also exert some gravitational force. So while it will not be able to pull the Earth's land masses, it does have an influence on the water bodies, due to which the oceanic regions, they experience a kind of a slight variation in the vertical height, and that is what we refer to as tides, which we will study later. Now we take a look at the basic formation of the moon. How is it that moon was created? So basically, for this, you have the giant impact hypothesis, which is postulated. What is this giant impact hypothesis? This is also referred to as the big splash. So as per this hypothesis, moon was formed due to impact of a collision between the very initial stage of planet Earth, when planet Earth was still not as solidified as it is today, roughly around 4 to 4.5 billion years back, when even the crust was still getting solidified. At that point of time, you had a very large, almost Mars-sized object, which is referred to as Theia, that came and collided with the planet. Now that Theia, when it collided with planet Earth, it created a huge splash. And because of that, huge amount of debris that was expelled from the surface of the planet Earth. Now those debris, they started rotating around the Earth in a form of a disk, something very similar to what you find as rings of Saturn in the present day. But then eventually, again, by the process of accretion, all those objects, they started colliding and coalescing together. And that is what led to the formation of what we refer to as moon. So that is how moon came into existence and moon was created. So here you observe a large collision, a giant collision, followed by this process of accretion. Now, once we talk about the moon, here, moon is tidally locked to Earth. What does this mean? This means that while the moon continues to revolve and rotate around the Earth, we always end up seeing and facing only one side of the moon. We don't end up seeing the other side of the moon. So always you will observe, let's say, let's take a case where we, let's say, have this portion of the moon which is facing the earth. You'll find that as moon moves into its next position, again, you will have the same phase which is directed towards the earth. Again, as the moon moves into the next phase, again, you will have the same phase facing the earth. Again, the same phase will face the earth or will be directed towards the earth. So it is a kind of a synchronous rotation which happens. The moon does rotate. Eventually, it does rotate, but it does rotate as it keeps on revolving around the earth in such a way that we are able to look at only one side of the moon. The other side of the moon, that is something which we are not able to look at when we look at it from the surface of the planet. That is why the other side is also referred to as the dark side of the moon, because that is not visible from the planet Earth. Now here, we have seen that basically always moon shows one face to the earth. And why is that? Because it is tidally locked. What do we mean by the aspect of tidally locked? So basically, in the initial stages, as the moon started moving around the planet Earth, initially, because of the huge amount of gravitational pull of attraction of planet Earth, its rotation slowed down. Earlier, it would rotate quite significantly, but its rotation slowed down. It slowed down to such an extent that now it is synchronized with its revolution around the Earth. The Earth has such a great amount of gravitational pull that it ensures that the side that it faces towards the Earth, that side continues to maintain its direction towards the planet. So, the Earth's gravitational interaction slowed down the moon's rotation until it became tidally locked. So, that is the aspect of moon's rotation. Now, here, just like the situation between planet Earth and the sun, similarly, moon also moves and revolves around planet Earth. So here again, you will have certain cases and certain situations where moon is significantly farther away from the earth, and in one position, moon will be closest from the earth. So when the location or the position of the moon is such that it is closest from the earth, here it is referred to as perigee. There it was perihelion because helion or sun was the reference point. Here you have perigee. G here refers to earth. So here earth is the reference point. So when we talk about perigee, the point on the moon's orbit when it is closest to the earth. So at that point of time, as you can observe, the distance does reduce to roughly around 363,000 kilometers from an average of around 388,000 kilometers or 384,000 kilometers. It does reduce slightly. And again, when the moon is farthest away from the earth, that is apogee, where the distance increases to roughly around 4 lakh kilometers away from the earth. Now, if we take a look at the overall perspective, you will observe that basically, when we talk about perigee, that is the moon's closest distance from the earth, you have apogee, the situation or the position where you have the moon's distance which is farthest from the earth. Similarly, you have perihelion, aphelion, all of them, they can happen simultaneously at different times as well. Now, on an average, the distance between the planet Earth and the sun, that on an average, which is taken to be roughly close to around 93 million miles, that is also sometimes referred to as 1 astronomical unit or 1 AU. So 1 astronomical unit, which roughly transcends to around 93 million miles of distance. 93 million miles is quite significant. That is referred to as, just as a kind of a measuring scale, it is referred to as 1 astronomical unit. Now, we have looked at the various different positions of sun, the earth, as well as the moon. There are various different instances when sometimes moon, due to its movement around the earth, does lie directly in between the path of sun and the earth. And also, there shall be certain instances when the position of the moon and in fact the position of earth will be in such a place where it will lie in the pathway of sun and the moon as well. Now that leads to occurrence of certain phenomena that we refer to as eclipse. So when we talk about eclipse, so eclipses occur when three heavenly bodies get aligned in the same straight line in such a way that visibility of one of those celestial objects that is disturbed. So you would all have heard about solar eclipse, lunar eclipse, which keeps on happening. Solar eclipse basically means eclipse of the sun. Eclipse, basically, if you look at the literal meaning of that and the literal translation of that in English, it is when something is basically shadowed upon and that particular object is not visible anymore. So when we talk about eclipse of the sun, we are talking about the situation in which the sun is no longer visible, but rather it appears as a darker object because it is hidden behind any other celestial object. In the case of planet Earth, this happens when moon does lie and does move into the pathway in between the sun and the earth. So let us take a brief look at what do we mean by solar eclipse and what do we mean by lunar eclipse. Now, here you would observe basically that you have the position of the earth and the position of the sun. Now, earth does receive significant amount of light from the sun on a daily basis, on a regular basis. Now, basically, it is that light from the sun which helps us experience the daytime, and the portion of the planet which is not visible or where the sun is not visible, there we experience nighttime. But then in those portions where sunlight is available, but then in certain small areas and for certain small durations, if it happens that moon does come in the pathway, what happens as a result of that? The solar light which would have otherwise fell on the planet, there you have creation of a shadow. So imagine an individual who is present in this area. Now, for this individual, that person will not be able to look at the sun or will not be able to see the sun because sun will be hidden by the shadow created by the moon. Just like when you shine a torchlight on, let's say, a particular table, and if you put your hand in front of that torchlight, the torchlight won't be visible from the table. Something very similar happens. And why is it that the torchlight won't be visible? Because your hand will extend a shadow. So when we say solar eclipse, it is the shadow created by the moon on the planet Earth in such a way that in those portions you don't have the visibility of sunlight. Now, here again, if you take a deeper look into the shadow, anytime and in any of the situation, and this you can again practice it or carry out an experiment even at your home, where you shine a particular torchlight on, let's say, a dark room and in a wall on the dark room. Now, thereby, after a point of time, let's say the torchlight creates a kind of a illuminated portion on the wall. Now, suppose you start putting your hand slightly in the path of that torchlight. What do you experience? You experience a kind of a pale shadow, a partial shadow which is created of your hand, and you will also observe a kind of a darker shadow created by your hand. If you have not tried it till now, do try it. You will find a very startling kind of revelation that even your hand will have multiple different types of shadows. It will have a kind of a partial, brightish or lightish kind of shadow appearance and a kind of a darker one as well. Now, this is also observed when moon does come in the pathway between sun and the earth in such a way that one moon creates and does cast its own shadow. It will also have a full shadow portion in this area. It will have a complete shadow, and you will have a slightly lighter shadow or a brighter shadow area which will span across a larger region. So thereby you have different observations of eclipses in these cases. Now, this is the case or the situation of a solar eclipse. We would also observe this in the case of lunar eclipse as well. Because here you would observe that Earth lies in between the sun and the moon. Now here you would observe that the light emitted by the sun, here the shadow is created by the Earth, and that direct shadow or the full shadow will be so large, it will encompass the whole moon, the entirety of the moon. And the partial and the lighter shadow will have a broader range as well. Right? So this is something observed both in the case of solar as well as lunar eclipse. Now, here, the portion where you have a full shadow and the portion where you have a partial shadow, they are named differently. And accordingly, we have the naming as umbra and penumbra. When we say umbra, so that is the darkest region of a shadow where you have the full shadow which is experienced. That is always referred to as umbra. Now here, in that case, suppose you are an individual standing in the region on the planet, or let's say anywhere where you have the darkest of the shadow which appears, there you won't be able to observe the sun at all. Whereas the partial shadow is the region of penumbra. So it is the region in which only a portion of the light source is blocked by the obstructing or the occluding body. The entirety of it is not blocked. So here some partial view shall still be maintained, whereas in the case of umbra, you have a complete blocking. You have a complete blocking. Right? So in this case, observe that entirety of the sun will not be visible. Whereas in the case of penumbra, you have partial visibility, which is still maintained. Partial visibility of what? Partial visibility of the object. So here, observe the case of penumbra, where some part of it is still visible. Now, hereby, when we take a look at it, in the case of the shadow created by planet Earth, and let's say we talk about the motion of the moon through that region of the shadow, you will observe that initially it covers the region of penumbra, where it will still slightly be visible. Then when it enters the region of umbra or full shadow, there the moon won't be visible at all. Again after that, moon will transcend into the region of penumbra again. You will have penumbra again. Okay, so that is how moon is visible in certain portions of penumbra, but it is not at all visible. And this we are talking about the lunar eclipse only. Now, with that basic, when we talk about the aspect of, let's say, solar eclipse. So when we talk about solar eclipse. So basically, this happens when moon comes in between the sun and the earth in such a way that it casts a kind of a shadow on the surface of the planet. Now, it will cast a direct shadow, that is umbra, and it will cast an indirect shadow, that is penumbra. It will cast a kind of a direct shadow, right? So in those areas where it casts the direct shadow or umbra, there you will observe a total solar eclipse. The sun won't be visible at all. Whereas those portions where it casts a kind of a partial shadow or penumbra, some slight boundaries or some slight corner of the sun shall still be visible. Now, moon blocks the light of the sun from reaching the earth's surface and casts a shadow on planet Earth. This is the case that we refer to as the solar eclipse. Now, depending upon the distance of the moon from the earth during the solar eclipse, different types of solar eclipses can be observed. You have a partial solar eclipse as well as a total solar eclipse. There is another kind which is sometimes referred to as the annular solar eclipse. What we refer to as the annular. Now, what does the term annular stand for? When we say annular solar eclipse, annular here represents a kind of a ring-like formation. So just like you observe a kind of a thin ring, right? That is what is represented or is observed during the annular solar eclipse. In the case of the annular solar eclipse, you won't have the entirety of the sun blocked out. You won't have a corner of the sun which is visible. You have the entire ring that is visible. And in between, the middle portion of it won't be visible because it is blocked by the moon. Now, all this is dependent upon the position of the moon. When we say that moon has casted a umbra or a kind of a shadow which is so full that it falls in the category of umbra, then sun won't be visible at all. So that will be classified as a total solar eclipse. So think about it. In these areas, suppose the moon casts the shadow and moon casts an umbra in this region, you will observe a total eclipse in this region. Whereas whichever portions are covered under the region of penumbra, right? Whichever portions are covered in the region of penumbra, there you will have only partial solar eclipse. So that is why you would observe, and if you have not observed till now, observe it in the near future. Whenever you have a prediction that there is going to be a solar eclipse, you will always observe that there is a kind of a demarcation as well and a kind of a notification as well, that these are the areas where you will observe a total solar eclipse, and these are the areas where you will observe a partial solar eclipse. All that has got to do with which are the areas which will observe a full shadow and which are the areas which observe a kind of a partial shadow. But then, what is the situation of annular solar eclipse? When do we observe that? That also has got to do with the portion of umbra and penumbra. How is it so? Let us understand. The situation is created in such a way that the shadow is created, but still that shadow is not large enough to have a complete blockade of the sun. The border and the margins of the sun shall still be visible. That means the shadow is not large enough. When does that happen? That does happen when you have, let's say, the situation or the position of the sun. Then let's assume you have the position of the moon, and then you have planet Earth. Let's consider Earth. Now, if you have a full shadow or a region of umbra falling on Earth, means total solar eclipse. Partial shadow means partial solar eclipse. But then you can also have a kind of a situation where the shadow which is created, the full shadow, the complete shadow, that is going to fall in front of the planet's surface. Think about it. So in this case, what do you observe? You will observe that basically, if you consider the entire area where you have a kind of a partial shadow which is created, so in this entire region, a partial shadow will be created. But what about the zone of umbra or a full shadow or a complete coverage? So here, observe that the portion of umbra falls before the surface of the earth. So when you have the full shadow or umbra does not lie on the surface of the earth, but it falls before the surface of earth itself. So a person who is standing in this position, let's say, for them, the corner and the ring of the sun will still be visible. The entire view of the sun will not be blocked. So annular solar eclipse is observed when umbra lies before the surface of the earth. Surface of earth in such a way that where the ring or a kind of an outer sphere, outer ring-like portion of the sun is still visible, of sun is visible. So that is what we talk about as annular solar eclipse. In this, you would observe a kind of a beautiful ring-like structure, and in between a complete dark shadow created by the moon. So that is the aspect of solar eclipse. So when moon does not align completely with the sun and only a portion of sunlight is blocked, there you can observe a kind of a partial solar eclipse. Observe this partial solar eclipse where not the entirety of the sun is hidden, but some portion of it is hidden. So these areas are the ones where you have penumbra, which is experienced. So in these areas, penumbra is experienced. Penumbra, when we say, we talk about a kind of a partial shadow that is experienced. Okay? Now, then after that, you have the situation of umbra as well, but this is the position of partial solar eclipse. Observe in these areas, you will observe a kind of a partial eclipse, that some part of the sun will be visible, but the entire blockage won't happen. Some part of it will be hidden as well. Now, in the case of a total solar eclipse, the moon is situated in such a position that it manages to block the complete view of the sun, and these are the areas where you experience the condition of umbra. These are those areas where you experience the conditions of umbra to be prevalent. So moon completely covers the disk of the sun, and only the sun's corona, that is the outer atmosphere, is visible. Only a small area on earth can witness it. Which areas? Wherever you have the incidence of umbra which lies, those areas will be able to observe it. So observe a kind of a full shadow being cast in this region. So in this area, a complete blockade will happen. So we have seen three different types of solar eclipses. We have seen a full solar eclipse or a total solar eclipse, a partial solar eclipse, as well as an annular solar eclipse. The only difference in the case of a total solar eclipse and a kind of an annular solar eclipse is, in the annular solar eclipse, this position of umbra does not fall on the Earth's surface but falls before it itself, due to which the outer boundaries are always visible. Okay, so that is the aspect of solar eclipses. When we talk about the lunar eclipse, here it is the eclipse of the moon. That is, the moon is not visible. First of all, why is it that we are able to look at the moon? Why is it that moon shines in the night sky? Is it because moon emits a light of its own? No. It is simply because of the fact that moon reflects the light received from the sun. So, if that light received from the sun in itself is blocked, the visibility of moon will not happen, will not be experienced. So, when Earth does lie in the pathway between the sun and the moon almost disappears and is not visible at all. And that is referred to as the eclipse of the moon or the lunar eclipse. Now here, it takes place when moon moves into the Earth's shadow or umbra. So this Earth will also exert its own umbra and penumbra, and that will cast a kind of a full shadow that we refer to as lunar eclipse. Now, when we think about the whole event and sequence, how it unfolds itself, basically, moon, first of all, will move in the penumbra position of the Earth, right? And causing a part of the moon's disk which will look to be absolutely dimmer. Some part of it will still be visible, but some part of it will appear to be very, very dim. And thereby, moon after that moves into Earth's umbra, and then it is totally invisible and totally it is blocked. The sunlight is blocked by the Earth's shadow. So here you observe, in the case of a lunar eclipse, if we consider this to be position of the sun, here in both these cases, let's say, consider this to be position of the sun. Here, when the moon's position is in penumbra, any of these penumbras, you'll find that a portion appears to be absolutely dimmer. This is the portion which still manages to receive direct light, whereas here you have a kind of a partial shadow. After this, the moon will enter into the total umbra position, and that is when you will have a total lunar eclipse or a complete lunar eclipse, when none of the moon will be visible. Now, after this, sometimes we also experience what is referred to as blood moon. So what is blood moon? So basically, when the whole of the lunar disk enters the Earth's umbra, the moon appears to be quite significantly reddish. And that is because of a kind of a diffusion of light which happens, and that is also what is sometimes referred to as blood moon. Now, in this complete chapter, we have overall looked at the position of Earth, Sun, the Moon, the properties of them, and thereby we have seen that how various different events unfold themselves. We have seen that how the position of Moon basically ends up imparting different kinds of appearances and different types of phenomena such as solar as well as lunar eclipses. In situations when the light is able to diffuse itself in such a way that you have a kind of a reddish appearance of the moon, that is what we refer to as the blood moon as well, where reddish light falls upon the moon. But then, if we recap the entirety of this module and this entirety of the session, we have basically looked at and concentrated at various different portions, starting from the universe, the formation of the solar system, the various theories in existence, the Big Bang theory, the most acceptable one out of them. What was the theory of expanding universe? We have looked at the properties of the formation of the planet, which we will further reinforce when we come to the portion of geomorphology. We have also looked at the portions regarding the properties of the sun, Milankovitch cycles or the glacial cycles that Earth passes through, and the portion of the moon, its formation, as well as the various eclipses. Time and again, UPSC will frame objective type of questions from this. For example, once UPSC had asked that what is meant by Goldilocks zone. So the habitable region or the habitable portion at a distance from the star where water can exist in a liquid form and temperature can be existent in a moderate state. So that kind of questions can always be asked. Let us take a look at a couple of these questions. One objective question, we'll take a look at it, and also one subjective. Now, which of the following phenomena might have influenced the evolution of organisms? So when we say evolution of organisms, basically we are talking about the adaptations that organisms have to go through in order to have a suitability in the current existing environmental setup. If, let's say, the temperature of the planet suddenly changes, the organisms which are living on the planet, they will have to adapt themselves. Their body will have certain changes which will happen over a long period of time. And that is the evolutionary cycle. Mankind also has evolved quite significantly for the past historical ages. So when we talk about which of the events which have led to evolution of organisms, continental drift or glacial cycles, both of them will stand to be the truthful scenario which have led to the evolution. How? Because when continents they do drift, when we will look at continental drift theory, etc., when the continents they do drift, they move from one area experiencing a different climatic condition to another area having a completely different climatic setup. So the organisms living in those areas, they have to adapt themselves to the changing climate. And so is the case with the glacial cycles as well. So in this case, both 1 and 2, they will be the correct answer. Both of them would have led to evolution of organisms. Now, a kind of a subjective question has also been framed by UPSC previously from this area, and that is, how does the Juno mission of NASA help to understand the origin and evolution of Earth? Now here, when we talk about these types of questions, here UPSC is checking multiple things out of a candidate. The candidate should be aware that what this Juno mission is, what it was, and then after that apply it to the planet Earth. So Juno mission of NASA, that was basically launched in order to understand the portion of Jupiter, the planet of Jupiter, in a better way, in order to understand the gaseous circulations which happen on the planet on a regular basis. So that was the basic purpose of that Juno mission. So in the introduction part of this answer, you can write about the Juno mission of NASA, which is a kind of an orbiter mission to Jupiter. Now, after that, one by one, you can write in various points that once we are able to understand the formation of these gaseous giants, not only will we be able to understand the gravitational pull exerted by that, which also leads to slight changes in the orbit of the planet Earth, but simultaneously, it helps us understand how the accretion model works. And how is it that various different gases would have come together to form this gas giant? Once we are aware of that, then we can always extrapolate that study in order to understand the formation of planet Earth as well. So basically, you can write in points that how it helps understand the evolution of atmosphere, study of magnetosphere and the magnetic field exerted by the various different planets, and Jupiter's mass also holds the original composition tracing the history of our solar system. The Jupiter's moon will also help us understand how our own moon could have been created, what are the properties, and few of these Jupiter's moons, they have ideal conditions and temperatures which can also support life. So greater amount of study is always required in order to understand the histories of our solar system and its formation. So that is something that can be summarized. And always, while writing conclusion to these sort of questions, always frame your conclusion in a way that more study, more research needs to be carried out in order to understand this process in a better manner, in a better way. Okay? Now, if we take a look at prospective questions which can be asked from this area, so we can have again multiple choice type of questions which can be asked. For example, consider the following pairs and we have to match the event to the date when it happens. So aphelion, that happens when? That is 4th of July. Is it correct? So basically, that is when it is farthest away. So this is correct. Perihelion, when it is closest, the Earth is closest to the Sun. That happens on 3rd of January. So we know that 1 and 2 are correct. Then summer solstice is when we have the longest days in existence across the northern hemisphere. That happens on 21st and 22nd of June. This in much greater detail you will study in the portion of latitudes and longitudes as well. So do cover that portion immediately after this to gain a more in-depth idea about what do we mean by summer season, winter season, summer solstice, winter solstice, what is the position of sun during the different times of the year. So do look into that chapter of the basics regarding latitude and longitude. But just to give you a kind of a hint that summer solstice does happen during the time of 21 or 22nd of June when we have the longest day and the shortest night. So all these three are correctly matched. So the answer will be D, that is all the above. Now, a kind of a subjective question which can be framed that what is Milankovitch cycle? Explain the factors influencing the cycle. So how do you frame that answer? So in the introduction part, very clearly, we can write about the aspect of the Milankovitch cycle that Milutin Milankovitch, he came upon a discovery that the Earth's phases of heating and cooling, they are dependent upon the distance from the Earth and the Sun, and also the amount of heating received in various different parts of the planet during various different parts of the year. That can be the concise introduction. In the body part, then you mention the various different aspects such as obliquity or actual tilt of Earth, the eccentricity, as well as the portion of precision, and thereby each of them you can elaborate with the help of diagrams. Always when you are writing answers for geography, always do include diagrams in that portion that will enrich your answer. And then eventually you can conclude with the significance of this cycle, that how it helps us understand the rate of heating and cooling of the planet. And that also helps us understand that why certain different areas, even though they were not deserts, for example, going back million of years, but now they are vast deserts. So it helps us understand the phases of evolution and the stages of evolution of planet Earth, and thereby also helps us predict the nearby future as well. So this basically completes the session, and this completes the entire basic regarding the universe. The remaining portion of universe you will study in the portion of science and tech as well, regarding what do we mean by dark matter, what do we mean by gravitational waves. All those portions you will study, but this basic portion will lay the foundation which will help you understand even those topics. After this, I would advise you to cover the basic portion of latitudes and longitudes, and thereby gain a significantly interrelated concept between the Earth's revolution around the sun, occurrence of various seasons, and the aspects of solstices as well. Thank you.